Welcome to the DIY Honda Garage channel. The DTC P1298 refers to an ELD Circuit High Voltage issue in the Honda CR-V models from 2011 to 2016. This diagnostic trouble code indicates that there is an abnormal voltage detected in the electric load detector ELD circuit. The ELD is a critical component that monitors the electrical load in the vehicle to optimize engine performance and fuel efficiency. It is typically located in the underhood fuse relay box. When the ELD circuit is functioning correctly, it communicates load data to the powertrain control module, PCM, which adjusts various functions accordingly. The detection of high voltage can lead to improper vehicle operation, hence the need for immediate troubleshooting. The ELD, or electric load detector, plays a significant role in maintaining the vehicle's electrical system efficiency and performance. It detects the electrical load current and informs the PCM about it, which adjusts the engine's performance parameters. This component is situated in the underhood fuse relay box. The PCM relies on accurate ELD signals to optimize fuel consumption and manage engine functions. When the DTC P1298 is triggered, it signifies that high voltage is detected in the ELD circuit, disrupting normal operations and resulting in potential engine or fuel efficiency issues. A faulty ELD can lead to incorrect adjustments by the PCM, which may present various performance problems. The DTC P1298 can stem from several potential causes. Firstly, detecting high voltage in the ELD circuit usually indicates an electrical problem, which may be due to excessive voltage from the battery or grounding issues. Secondly, open circuits in the wiring that connect the ELD to the other components can fail, leading to no signal transmission to the PCM. This can happen owing to damaged or corroded wires. Lastly, a faulty ELD itself can be the source of the problem, where its internal components fail to function correctly. Each of these scenarios must be considered during troubleshooting to ensure an accurate diagnosis. When DTC P1298 is activated, several symptoms may manifest, impacting the driver's experience. One key symptom is poor engine performance, possibly due to the PCM not receiving accurate load data from the ELD. Consequently, the vehicle may experience unintended loss of power or engine hesitation during acceleration. Additionally, erratic fuel consumption can occur, resulting in increased fuel cost without substantial driving distance. Drivers may also notice warning lights illuminated on the dashboard, indicating system malfunctions. These symptoms collectively compromise the driving experience and necessitate prompt attention to ensure safe and efficient vehicle operation. To begin troubleshooting DTC P1298, the first step involves verifying the problem by turning the ignition switch to the on position, which is commonly referred to as the II position. Using the Honda Diagnostic System, HDS, the electric load value should be checked. Ensure that the value is less than 0.2 amps, as this threshold helps identify whether the current conditions align with the expected operational limits. If the electric load value confirms this condition, then the failure is successfully duplicated, and you can proceed to the next step. However, if it does not match, it indicates an intermittent failure, suggesting that the system may be operating normally at that moment. In such a case, further inspection may be required to check for poor electrical connections or loose terminals at both the underhood fuse relay box and the PCM. The second step in troubleshooting this DTC requires the ignition switch to be turned to the lock position, which effectively powers down the vehicle's electrical systems. Next, you need to disconnect the underhood fuse relay box 3P connector to isolate the circuit for further testing. With the connector now disconnected, turn the ignition back to the on position too. It is essential to measure the voltage between the specified test points. The underhood fuse relay box 3P connector at test point 1, which corresponds to number 3, red, and AUDI ground at test point 2. If battery voltage is present, this confirms that the IG1 ACG wire is functioning properly, and you can move on to the next step. But if there is no voltage detected, you will need to check the number B215A fuse located in the under dash fuse relay box. If that fuse is intact, the investigation should focus on the IG1 ACG wire integrity between the B2 fuse and the underhood fuse relay box. In troubleshooting step 3, the process begins with turning the ignition switch to the lock position once again to ensure safety before proceeding. The next task involves jumping the SCS line using the HDS, which stands for the SRS console system, as this allows for diagnostic continuity testing. Following this, it's crucial to disconnect the PCM connector A, specifically the 49P connector. With the PCM disconnected, check for continuity between the defined test points. Point 1 at the PCM connector A, 49P, number 34, white, and point 2 at the underhood fuse relay box, 3P connector number 1, white. This test is aimed at confirming whether the ELD, electric load detector wire, is operational. If there is continuity, then the wire is confirmed to be intact, allowing you to progress to the next diagnostic step. Conversely, if there is no continuity, it indicates an open circuit in the ELD wire that must be repaired between the PCM and the underhood fuse relay box. Step 4 focuses on verifying the continuity of the ground line related to the ELD circuit. Start this step by maintaining the ignition switch in the lock position and ensuring that both the underhood fuse relay box 3P connector and PCM connector A, 49P, remain disconnected. Continuity must be checked between the specified test points. Point 1 at the underhood fuse relay box 3P connector number 2, GRI, and point 2, which is body ground. This test serves to ensure that the ground circuit is functioning correctly, since a poor ground can lead to erroneous voltage readings and may trigger the DTC P1298. If continuity exists, the ground line is deemed functional, thus allowing progress to the next troubleshooting step. Conversely, if continuity does not exist, you'll need to repair the open circuit in the ground wire linking the underhood fuse relay box and G302. This is essential for maintaining proper circuit function. The final troubleshooting step involves a hands-on approach to testing the ELD component directly. Start by substituting the original ELD with a known good replacement part to eliminate the possibility of a faulty ELD. Once replaced, turn the ignition switch to the on position 2. Prior to proceeding, it may be beneficial to reset the PCM using the HDS, which allows the system to reinitializing with updated parameters. Following the reset, the PCM idle learn procedure should be completed to allow the PCM to adjust to the new component effectively. After these actions, using the HDS, check for any pending or confirmed DTCs. If DTC P1298 still appears, it suggests that further issues may relate to the PCM itself, potentially requiring an update to ensure it has the latest software or even a substitution with a known good PCM. If DTC P1298 does not appear, then the original ELD is confirmed faulty. Final repair verification is critical to ascertain that all corrective actions have resolved the DTC P1298 effectively. This process begins by turning the ignition switch to the lock position to ensure safety while reconnecting all previously disconnected connectors. After securely reconnecting, turn the ignition switch back to the on position 2. Subsequently, the PCM should be reset once again using the HDS to clear any residual error codes and ensure effective communication with the network of vehicle systems. Completing the PCM idle learn procedure is essential at this stage, allowing the system to recalibrate any parameters as required. Finally, check for any pending or confirmed DTCs once more with the HDS. If the DTC P1298 remains, it indicates that further inspection for connection issues is required. If not indicated, troubleshooting can be considered complete. Preventive maintenance plays an essential role in averting reoccurrence of DTC P1298. Regular inspections of all electrical connectors are advisable since poor connections can lead to high resistance and potential high voltage readings. Ensuring that connectors are clean and secure can dramatically reduce risks. Furthermore, periodic checks of the ELD's performance parameters should be executed. This can be done using diagnostic tools that monitor the electric load values the ELD provides. Should any discrepancies arise, they should be addressed promptly. Engaging in these proactive measures helps maintain reliable engine performance and optimizes fuel efficiency in the long run, ultimately contributing to a better driving experience. In summary, understanding DTC P1298 and its implications for the Honda CR-V from 2011 to 2016 is crucial for vehicle maintenance and performance. The ELD is a key component that must function optimally for efficient engine management. By carefully following the outlined troubleshooting steps, you can diagnose and address faults associated with high voltage in the ELD circuit. Remember to verify all connections and conduct preventive maintenance to reduce the chances of future errors. Promptly addressing any arising issues ensures your vehicle continues to perform reliably and efficiently, ultimately enhancing your overall driving experience. Always prioritize maintaining the electrical systems and components for long-term vehicle health. Please like and subscribe to the channel. See you next time.